Welcome everybody to your free GMAT prep hour. My name is Reed Arnold. It is August 1st, 2021. Glad you are here. Hope your GMAT studies are going well. I hope you're finding these resources useful. If you are looking for other free Manhattan Prep resources, we have a few available for you. The first thing to say is that you can try out the first class of any of our 9-week sessions for free. That is over 10% of the entire course that you don't have to pay anything for. Sign up. Try it out, see if you like our vibe, see if you like the teacher's vibe. We talk about huge stuff in section 1. We talk about data sufficiency. We give a big overview of what the GMAT actually is and what it's testing. We talk about some major sentence structure, sentence correction strategies. So it's just a really, really good resource out there. And I always say don't tell my company, but you might as well go take it. It's free. You don't have to pay anything. It's just a big lesson. No reason not to do it. You can do a similar thing with our Interact course. That's our live, or not a live, excuse me, our self-paced video course. Really, really neat program. It's the kind of thing similar to the test. It adapts to you. If you get a question right, the program says, great, let's try a harder question. And if you get a question wrong, the program says, okay, well, let's go into an easier version of this question and make sure we're solid on the foundation. So it's just a really, for being a video course, it's very tailored to your needs based on your answers. Okay, so it's just a good thing to try out there. Also, a few months ago, we made our Foundations of GMAT Math workshop completely free. You can sign up to either a 1-day, 7-hour workshop with a 1-hour break, or it's 3.5 hours split over 2 days. We really talk about the foundations of math in a GMAT way. I think it's a really neat course. It's one of my favorite to teach. I think that it's useful for even people who are scoring really highly on the GMAT. You know, when I first took the course, before I taught the course, it changed the way I thought about numbers and the way I did certain arithmetic. And it's just a really, really wonderful course, totally free. If you can't make the dates that we have set up, you can also get a video version of the course for free, including the homework syllabus that comes with it. So really, really nifty free resource out there for you. Okay. So today's lesson, everybody, we are talking about inference chains, or what I'm calling inference chains. This is a continuation of something that I started to do in my most recent free prep hour called I think it's called the 5 ways to improve a GMAT score, something like that. And I talked about the 5 ways that I know that one could make their GMAT score better. And the last thing I mentioned was inference opportunities. The GMAT is very often a game of being able to recognize where you can make an inference and what inference can be made. A logical inference, something that has to follow based on what else is there and based on some simple rules of, you know, grammar, logic, and math, arithmetic, and whatnot, algebra. Okay, very often they're using these subjects as proxies to see how well you do this, how well you synthesize information, how well you make logical inferences. They're not really so interested in, hey, do you remember how to get the area of a circle? No one really cares. They're using the area of a circle as a subject that everyone has been exposed to at some point in their life to see how well you make logical inferences through a problem and answer a question that is asked. Okay, and so when I was laying out, or when I was discussing inferences, we talked about the 2 mistakes that can be made regarding inferences. You can either make a mistake that you should not make. I'm sorry, you make an inference that should not be made. You say something is true that doesn't have to be true, or you don't make an inference that should be made. Those are the 2 kinds of inference mistakes. Okay, and in many ways, every GMAT mistake is one of these. If you get a question wrong, it's because you either made an inference you shouldn't, or you didn't make an inference that you should, one or the other. What does it mean to make an inference you should not make? How does one make an inference that should not be made? Well, you either make up a rule or mechanic that doesn't exist or is not allowed in that situation. You know, some people, for instance, like when they get back to fractions, if they see something like x plus y over y, then I'd be like, well, I can get rid of the y because it's on top and bottom in a fraction. Well, you can't really do that mechanic with addition. If it's x times y over y, you can, but not x plus y over y. So it would be an incorrect inference to say x plus y over y equals x. That would not be a good inference to make. Okay, and so that's using a rule or mechanic that does not exist or is not permissible in that particular scenario. When you make an inference you shouldn't make, you might make an assumption that is not actually known or given, but you just assume something to be true. You might misread or misinterpret a sentence or a detail or something about an equation. You might make an inference that's really close to the inference that's supposed to be made, but is either not, it's not precise enough. You didn't get specific enough. You went to something too general and overlooked some of the specifics about the inference that should be made. If you do not make an inference that should be made, several reasons why this might happen. These are just a few. This is not an exhaustive list, but maybe you did not know a concept, rule, or formula. Maybe you did not see to use, I think this is probably the more common one, you did not see to use a concept, rule, or formula that was applicable. Maybe you did not use a piece of given information. You forgot it. You didn't write it down. You lost it in the problem. You didn't see to use it to make an inference. Maybe you did not see the specific inference implied something general. What I mean by that is, if I know that Paul owns a cat, then I know that some people own animals. Like, that generic situation must be true since Paul owns a cat. That specific inference allowed something general. That's especially tricky in reading comp. A lot of reading comp answers go to the more like general state from the specific inferences or from the specific details. You might misread, misinterpret, misunderstand what's given. That's always a risk here. You don't rephrase or transform the information into something clearer or more useful to see what inference can be made. Maybe you don't recognize how two pieces of information synthesize, possibly because you don't know the concept, rule, or formula. Again, this is not an exhaustive list, but these are just some things to be on the lookout for. Why did I not see to make an inference that I could make? I had another thought about inference making and about the kinds of mistakes. What was it? Oh, if it comes back to me, I will say it. Okay, but that's what we're talking about today. We're talking about inferences and how to make inferences. I remember what it was. So today we are specifically talking about inferences that can be made on problem-solving quant questions, and we're really going to lay out a review strategy for when you do a question and you're reviewing a question. This is not something you would do on the test, what we're going to kind of talk about today, but it is a way to help you review a question and really specify where the inferences are and why and how you can make them. So it's a really useful tool to drill down and figure out, where am I snagging? Where am I making inferences I shouldn't, or where am I not making inferences I should? And by doing this exercise we're going to lay out today, it's really going to hammer home, and you'll really be able to put under a microscope and figure out where something is not clicking. So let's start with the warm-up problem here. Go ahead and take 2 minutes for this question, and I will use it to demonstrate the exercise we are going to talk about today. All right, gang, that is 2 minutes. Go ahead and choose an answer if you don't have one. Just curious what's out there in the room. If it's a guess, you feel free to put a question mark by it. I'll make sure I'm not going crazy. I don't see any answers coming in. We're hesitant to choose the wrong letter. Okay, guess A with a question mark. Don't be afraid of choosing the wrong letter on this test, everybody. The test is going to make you choose the wrong letter often. The fear of the wrong letter is one of the biggest things to overcome while you study. So a few A's coming in. And A is the right answer. So here's just a quick example of what my scratch work might look like as I worked on this question. Okay, I know I have 12-ounce cans, that's given here. Concentrate, I know I mix 1 can of concentrate with 3 cans of water. Well, okay, that means there's 48 ounces of orange juice made with each can of concentrate. And I know I want 1,200 ounces total because it's 206 ounce serving. So I do 1,200 ounces total divided by 48 ounces each can. That's going to give me 25. And if that's, how do you do 1,200 divided by 48? Well, I'd probably start saying, okay, well, that's 600 over 24, 300 over 12. And I would say, oh, well, 300 is 60 times 5. And 60 over 12, I shouldn't have crossed off that 12 yet. 300 is 60 times 5, and 60 divided by 12 is 5. So that's going to end up with 5 times 5, which is 25. So I would choose A, and that would be good to go. Okay, great. So that's the answer. The answer is A. That's not really what I'm interested in today. Maybe you got this right, maybe you didn't, whatever it was. Let's say you go to an explanation, and you read the explanation, and you read through, and you kind of like, this is the explanation someone gives. What I want you to start practicing is to start recognizing, because it's very easy. Here's the thought. It's very easy to read someone's explanation and just say, like, that makes sense. Yeah, that's the right answer. Of course, that's the right answer. That's everything you wrote made sense. But it's too easy to read good reasoning and feel like you've done something. I want you to really make reviewing a question active. Right. And in fact, a little study tip, you should never, ever read a full explanation from top to bottom, ever. You should always read an explanation until you get to a moment that has a new thought, where something you didn't try, and then you don't finish the explanation. You go from there and see how far you can get. Okay. You want to use explanations as hints. They give you little nuggets of thought that you can then take and practice as much as you can. But it's too easy to just read an explanation and say, oh yeah, that's the right answer, and that reasoning looks good to go. You just don't get as much out of it as if you're actively trying. But eventually, you do the whole thing. You either finish the question on your own, or you go back and forth between the explanation, and you get to something that's like, okay, I see what this person did. What I want you to do is identify where and how inferences are made and put them into a map of inferences. Something like this, like identify what pieces of information synthesize to give you a new piece of information. Like map what the logic is actually doing. Right here I had 1 can of concentrate mixed with 3 cans of water, and I had 12 ounces per can. That allows me to make an inference of 48 ounces of orange juice with each can of concentrate. If I have 200 servings and 6-ounce servings, that gives me 1,200 total ounces of orange juice. If I have 1,200 ounces of orange juice and 48 ounces with each can of concentrate, that allows me to make the final inference that there's 25 cans of concentrate needed. Okay, and you really specify where each inference is made, and drill into how it's made, why you're allowed to make it, what rule are you using, what concept are you using, what formula, whatever it is. Why is that inference allowed? This question is using repeated examples of what I call the GMAT's favorite equation. I still might do a full class on this, a full free prep hour on this sometime. And the GMAT's favorite equation is total A equals A's per B times total B. Right? This is 200 servings. So total ounces equals ounces per serving times total servings. That's 6 ounces per serving times 200. So that gives me 1,200. This right here, the 1,200 total ounces equals ounces per can of concentrate times cans of concentrate. This is that last inference. Okay, and I know that I have 48 ounces per can of concentrate times the thing I want, right? How many cans of concentrate are there? So the inferences that I'm making here are really repeated uses of the GMAT's favorite equation. And so that's a good thing to look out for. The GMAT likes this game. Okay. But I see what information there is. I see how it synthesizes. I see what inferences I can make. And I can really zoom in on the inferences that cause me the most grief and figure out what I needed to think about to make that inference. What does someone who makes that inference notice? Because here's the thing, gang. What does the GMAT actually care about? Here's the problem that I had. Okay. Here's the inference chain that I made. Here's just a slight rewrite of that problem. Basically the same information, but what I've done is I've taken it and instead of giving it as fact, I'm giving if-then. If a can is 12 ounces, if a serving is 6 ounces, if 200 servings are required, right? Yeah, it's just a subtle rewrite of the question. But if I take that, okay, and I abstract, I take out all the specifics. Instead of according to a directions of a can of frozen, it's just according to something. There's something. There's some fact, right? According to the directions, 1 can is mixed with 3 cans of water. Okay, so according to something, a fact. If B and if C and if D, what can I know? Right? This is the specific situation with orange juice concentrate and water. The GMAT is much more interested in this logical map. It's not so interested in cans of concentrate and orange juice. It's interested in, hey, can you organize thoughts and make logical inferences in a repeated, organized fashion to go from given information to answer to a question? Okay. So one thing I'm hoping we do get out of this, besides just a new tool to review problem solving questions, and I do think I'm working on ways to use a similar thing for other question types, because I think this kind of thing will be iteratable. I don't know. I think you will be able to use it for other question types, but it works best with problem solving, at least right now in my mind. But one thing I want you to leave today, aside from this tool, is kind of a newfound respect for what makes a problem difficult and what your brain does when it gets a question right. This is not the most mind-blowing inference map, perhaps, but we're going to see some that, you know, are pretty gnarly. And you will get I think a newfound respect for, like, oh my gosh, my brain has to do so much to get from question to answer. And you'll understand that that's what they're testing you on, is can you get your brain organized, your thoughts organized to move through a logical structure to go from these givens to this answer. Okay. Because that will help you know what you need to get better at and where you need to improve. Another example of this is you can find multiple maps for each, for question. Often for a question, you can find multiple maps, right? The original question, the original map I had to look something like this. Well, I could also take that 48 ounces of orange juice, okay, and if each serving is 8 ounces, I should probably put that here, right? Each serving is 8 ounces. I'm sorry, 6 ounces, excuse me. Each serving 6 ounces. If I take that information, I can synthesize to make an inference of, oh, well, then each can of concentrate makes 8 of those servings. And I need 200 of those servings. So GMAT's favorite equation, 200 servings equals 8 servings per can times how many cans? 200 over 8 equals 25. So I get to the same endpoint. I just go a little bit different inference path. You could also go a different inference path. You can recognize that this is a ratio. 1 can of concentrate to 3 cans of water, that means the ratio is going to be 1 to 3. And then if I know that there's 1,200 ounces total and it's a 1 to 3 ratio, I'm sorry, yeah, 1 to 3, it'll be 900 ounces of water, 300 ounces of concentrate for 1,200 ounces total. Well, if I have 300 ounces of concentrate and there's 12 ounces a can, there's 25 again. So another inference path. Or I could use the answer choices. Okay, if I start with these amounts of cans of concentrate and water, and I have 34 cans of concentrate, that gives me 102 cans of water. That gives me 136 total cans. That gives me more than 1,200 ounces. Why? Because 136 total cans times 12 ounces a can is greater than 136 times 10. Well, bigger than 200 ounces when I'm supposed to have 1,200 ounces means 34 cans is too many, means 25 cans of concentrate are needed. Okay, so this is all something this is a similar question I did in a previous free GMAT prep hour. But it just demonstrates how many inference paths there are. And your job when you review a question is to make a map like this, because it forces you to see where information synthesizes and what inferences you can make. And you can really zoom in on like which arrow gives me the most grief. Maybe it's that one. Why is that true? Or maybe it's this one. How do I get to 102 cans of water from this? Right? You can really, as you read someone's explanation and try to map out their logic on a piece of paper, you can see where something goes awry. You can also take the actual numbers. I think this is a good exercise too. And take the numbers out. Stop doing the math. Just use the information. If I know how many cans of concentrate to how many cans of water there are, and I know how many ounces per can, then I know how many ounces of OJ are made with each can of concentrate. That information, if I know this and I know this, then I know this. If I know how many ounces of OJ are made with each can of concentrate, and I know how much OJ needs to be made, then I know how many cans of concentrate are needed. And think about why. Why would that be the case? Well, it's that GMAT's favorite equation. Right? Total OJ equals OJ per can of concentrate times cans of concentrate. I really do want to do a free GMAT prep hour on that equation because it's just so pervasive. So this is the idea. And so we're going to do several examples today where we do questions and we just think about the inference chain that can be made. And if we can find multiple inference chains, like this is, again, this is several different paths to get from givens to answer. But that's what you want to review for. It's good practice to find multiple paths and to see how many inferences you can make. Okay. So next question here. Try this one. Take 2 minutes. Okay, that is 2 minutes. Go ahead and type in your answer. I have one answer of E, 16 root 2. I have one answer of B, 16. Regardless of another answer of B, regardless of whatever answer you chose, let's think about the inference chain that we can make. I think geometry questions are a good place to start with this exercise, because geometry really lets you see the inferences. You have a shape to label. Geometry in general is good practice for this logical progression, step by step. Use a piece, get a new piece. Use that piece, get a new piece. But every problem solving question can be broken down that way. To some degree, I mean, this is the inference chain. If I know the perimeter of the triangle and I know it's an isosceles right triangle, apparently, because that's all they give me, apparently that's enough to get the hypotenuse. Right? Apparently, if I know those two things, I can infer the hypotenuse. But if that's pretty broad. Let's break that down a little more specific. Let's see really how we can make that inference. Well, if I know it's an isosceles right triangle, I know the proportion of sides. And if you don't know this, here's your reminder, but this is something you'll be exposed to as you study for GMAT, right? I know these sides are the same, and I know that an isosceles right triangle gives me proportions of x, and x rad 2. And so if I know that, I can get the perimeter in proportions. It's going to be 2 times x plus x root 2. But I actually know the actual perimeter is 16 plus 16 root 2. Okay. Now it's very tempting at this point to say that, that the 16 root 2 is the perimeter, is the hypotenuse. Because it's like x root 2 and 16 root 2. So that's the same part, right? That's the same thing. But that would be making an inference that should not be made. And if you're anything like me, at this point, if you tried to set up, okay, I can set up an equation, right? 2x plus x root 2 equals 16 plus 16 root 2. If you tried to solve this equation, if you're anything like me, that was not easy. First time I tried this question, this was the first thing I got to, and I was like, I don't quite see how that's going to work for me. There's a way to do it, but it is not my favorite thing. And so at that point, I stopped and I thought, well, wait a second. I know the proportions. And I know that the proportions of an isosceles right triangle. And I know that one of these is the hypotenuse. And so what I can use is a strategy called backsolving, and I can make inferences from each of those possibilities. If I know it's an isosceles right triangle, and I know therefore the proportions of sides is that xx root 2 situation, okay, then from those possible hypotenuses, I can figure out the possible sides. Okay. If this is the x root 2, if this is the hypotenuse, then I know that x is going to be 8 over root 2. And 8 over root 2 equals 4 root 2. Okay. 16, 8 root 2, 4 root 2. The side's going to be 4. These are the easier ones to deal with. These are the harder ones to deal with, right? Because these have the nice root 2 as part of the thing. These do not take a little more work. If those are the ones that give you grief, going from 8 to the side, you might need to, okay, hold up. I need to work on my 45, 45, 90 triangles where the hypotenuse doesn't have a root 2 in it. That's the convenient case when it does have a root 2. If it doesn't, can I speed up that mechanic? Can I make that inference faster? I finally figured out, well, you just divide this by 2 and then multiply by root 2. Right? Whatever the hypotenuse is, divide it by 2 and multiply by root 2 to get the side length. Okay, so divide a by 2, it's 4. Multiply by root 2, it's 4 root 2. From there, once I know the possible hypotenuses and the possible sides, I can solve for the possible perimeters, right? If 4 is the side length and 4 root 2 is the hypotenuse, those become 8 plus 4 root 2, 4 plus 4 plus 4 root 2. If 16 is the side length, it becomes 32 plus 16 plus 16, 32 plus 16 root 2. But they actually give me the perimeter. It's 16 plus 16 root 2. So I know that second option is the answer, which means that the second option is the answer. Okay, they give me the actual perimeter. Which of these hypothetical situations actually matches the situation that I'm given? So this is a way to use an inference map with something like backsolving. You just make the inferences from each answer choice. You know, if this answer is the right answer, then this would be the side length. If that's the side length, then that would be the perimeter. If that's the perimeter, it matches the given perimeter. That's the right answer. Okay. And you're using the hypotenuses, right? What am I given? I'm given the isosceles, right? So I know it's x root 2. And then I know 5 possibilities for this value. Well, if those are the 5 possibilities, what inference can I make in each situation? The information just flows. Backsolving is all a game about making the inferences as far as you can and finding the one that keeps everything consistent with what is given. That's what backsolving is. Use the answer to make inferences, find which one actually matches the situation. Okay. Any questions about this so far? This question is probably hard intermediate. It's a mid 600s, maybe high 600s. But I don't have the data on me, and I'm not always a great gauge of that. It's some questions that I think are really hard turn out being pretty easy. Some questions that I think are pretty easy turn out being pretty hard. So. But this, I hope you would, if you looked at the explanation and it says backsolving is a good option here. Oh, interesting. How could I backsolve? How could I use these answers? What would the inference look like, right? You wouldn't necessarily, well, I say that. You might write this down. This might be, you might do basically a table that's like the hypotenuse, the sides, and the perimeter. This one, you might actually write down the full thing. So you'd say, 16, then the sides would be 8 root 2, and the perimeter would be 16 root 2 plus 16. Hey, that's what's given. That's this one. I was saying before, this is not how you would take the test. You would not write the info. You certainly wouldn't write this, right? This is not how you would take notes on the test. This is meant to be a representation of a mental map. You can then think about like, okay, what's the best organization for this mental map on the test? What would the scratch work look like? This particular example, that's actually not all that different from what your scratch work might look like. So you'll have a bit of both sometimes. Let's try another question here. Take 2 minutes for this problem. Okay, so what I'm going to do here is show you how I might do this problem with scratch work, and I want you to kind of think about and maybe write out what the inference map would look like. Okay. So what I might do is I'd say, well, okay, this is a square of a sum, so I can say that this would be 2 plus 2 root 10 plus 5, which equals 7 plus 2 root 10, which would be 7 plus about 6, which would equal about 13. And notice it does say closest approximation. That's excuse. That's not excuse. That's permission to estimate. So the answer here is C. So what inferences did I make, and what did I use to make them? Take a minute to think about that. All right, where did I get 2 plus 2 root 10 plus 5? Where did I get about 6? How did I make these inferences? If you're at home, you can pause and wait as long as you want, or work as long as you want. For those that are here, for the sake of time, I'm going to only give you a minute. Good, Tyler. Just now realizing that my screen might have been paused, so you might not be able to see the scratch work, but that's what the scratch work looks like. Good, Neil. Nice. All right, so this is basically the inference chain. Okay, and what did I use to make each inference? Well, I used, as Tyler said here, my square of a sum formula. X plus y squared equals x squared plus 2xy plus y squared. The better I know that formula, the faster I can make this inference to say, okay, well, this becomes 2 plus 2 root 10 plus 5. One of the trap answers here is to say 7, like, oh, well, this must be 2 plus 5, right? Root 2 squared plus root 5 squared, but that's not the inference you can make. That's not the mechanic. I need to use this formula with x plus y squared. So that allows me to get here. Well, okay, 2 plus 5 is 7. That gives me the 7. The root 3, well, you know, root 9 is 3. Root 10 is like a little bit more than 3, right? So I turn that into about 6, a little bit more than 6. 7 plus a little bit more than 6 is a little bit more than 13. 13 is the closest answer. Okay. Another way to do this, another inference chain I might have made, is to estimate root 2 and root 5. Those are values that you should have memorized, or at least estimations you should have memorized. Root 2 is about 1.4. Root 5 is about 2.2. So I could turn this into, well, that's about 1.4 plus 2.2 squared. Well, 1.4 plus 2.2 is about 3.6 squared. Then if I need to break down that last step again, well, 3.6 is between 3 and 4. 3 squared is 9. 4 squared is 16. So this is going to be somewhere between 9 and 16. You know, it's going to be like 12 to 14-ish. Oh, look, there's 13 right there in the middle. Perfect. Okay, so there's kind of 2 inference paths you can take here. I think either one works. Be good to practice both. Cool. Let's amp up the difficulty here. Take 2 minutes for this one. Okay, that is 2 minutes. Again, if you're working at home and you're watching a recording, feel free to pause and try a little bit longer. You don't want to go too long without choosing an answer, though. Get used to choosing letters. Yeah, so some of the people in the chat have seen this on a recent practice test. This is an official question from the official practice test, so you might have seen it before. Okay, so people are saying 40. Each number, each term in the sum, A1 plus A2 plus ... plus AN, so I'm adding some number of numbers together, is either a 7 or a 77. And the sum equals 350. So which of the following could be in, meaning which of the following could be how many numbers are in this sum? I'm actually curious about another way, but I don't want to do it mid-lesson. I might pause the recording and try it because I hadn't thought of doing it this way. But the way I did this question when I first saw it was like, well, okay, I could have 57s. Right, 57s, that equals 350. So I could have 57s. But 50 is not an answer. And so then it was a game of, well, okay, so I could have 57s and 0 77s. And if I bring in a 77, if I have 177, what does that do to my number of sevens? Bringing in a 77 does what to the number of sevens I have? I definitely reduce, I don't have 57s anymore. So if I have 57s and 177, that's going to be more than 350, right? So I definitely lose some sevens. How many sevens do I lose? Well, not 10, Mickey. I actually don't lose 10. I lose 11. Right? 177, right? 77 equals 7 times 11. So if I bring in 177, I lose 11 sevens. So I end up at 39 sevens, which would be 40 numbers. And that's the answer here is 40. And 57, I could have 50 or 40, and the answer is 40. So this was the first time I did this question. This is what my work looked like. This is what my scratch work looked like. So the question is, what does the inference map look like for this approach? Take a minute and try to actually construct an inference map for what the scratch work represented. And again, if you're at home, pause and spend as much time as you want doing this. I drink so much liqueur doing these, I feel like I should be a sponsor. They should be paying us. That's true, Neil. Since 50 is not an answer, we know there must be at least 177. That's true. The inference map I made for this example here looks like this. I know I have a number of sevens and a number of 77s, and they add to 350. Whether you keep this as, I could have written this as two pieces of information, right? I could have only sevens and 77s, and then the sum is 350. I could have written that as two pieces of information that synthesize into, you know, this down here. There's no objective way to make the inference map. You can keep it as two items. Sometimes you can just synthesize it to one. Okay, Neil said something interesting. I'm going to come back to that in a second, Neil. Okay, so, I mean, the answer to this one happened to be 40. They could have made an answer of 30 or 20 or 10. Sure, they could have done that. But it comes from, I have only 7s and 77s, but sum is 350. So I infer it could be 57s and 077s. And then, like, this is not given. They don't tell me that 77 equals 11 times 7. I'm just expected to know that. This is, you know, you're often expected to bring in some outside knowledge. Those are the formulas and rules in mathematics that the GMAT tests, including simple multiplication. So if 77 equals 11 sevens, then I can infer that 177 trades for 11 sevens. They're worth the same. And so from there, it's trading 177 for 11 sevens, and I'm getting these possibilities, which is 50 numbers, 40 numbers, 30 numbers, 20 numbers, 10 numbers. Now, Neil has noticed something. Neil has said, interesting, the value of n has to be a multiple of 10. We're going to come back to that in a moment. It does seem that the only answers here are multiples of 10. We'll come back to that in a moment here. Okay. Another way to do this is to realize that I can't have 5 77s. If I have 5 77s, that's too big. So I could have 4 77s and then work, same idea, it's just working from the other end. It's working from 4 77s, and this would take more math, take more arithmetic, which is kind of annoying, but it would take 6 sevens, and from there, okay, add 11 sevens, take away 77, add 11 sevens, take away 77, yada, 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 10, 20, 30, 40, 50. But what Neil has noticed is that, hold up, the answer must be a multiple of 10. And so what you want to look at, we haven't talked about this yet, but you want to look at your inference map and see if you can synthesize things even more. Okay, I mean, first is make sure that each arrow makes sense, right? Why would, like, this arrow is a helpful arrow. It's not immediately obvious that this is an inference one should make just because 77 equals 11 times 7. The inference that means I can trade 1 for 11, that's a pretty, I'm not trying to toot my own horn, like that's kind of a sophisticated inference to make. So make sure you really understand why that exists. And I'm realizing now it's the GMAT's favorite equation again, I think. Total 77s equals, it doesn't quite work. It's not quite the GMAT's favorite equation. Anyway, make sure you understand the arrows, but then look at your map and see where you can synthesize. See what other shortcuts you might make. If 177 trades for 11 sevens, each trade is a trade of 10 overall. I lose 11 and I gain 1. So I'd be losing 10 overall. Or I gain 11 and I lose 1, so that'd be gaining 10 overall. I'm always shifting in tens. And if I start at this point of 50 and I'm always trading in tens, the answer must be a multiple of 10. Very good observation, Neil. If you need to see why, because there's an unstated understanding that a multiple of 10 plus or minus a multiple of 10 equals a multiple of 10. This is a number property rule that the test uses a lot. Now, do you need to do this to answer this question? Of course not. I didn't the first time I did it, but it does help me for more advanced questions. This kind of understanding, this kind of inference is a more advanced inference and might make me better at more advanced questions. If I start at a multiple of 10 and I'm trading tens in tens, I'm going to end at a multiple of 10. There's only one answer that's multiple 10. So you kind of, push yourself to see, especially when you notice, if you notice this, which I suspect Neil did, like, hold up, those are all multiples of 10. Why? Why are they all multiples of 10? Oh, I see. Because the trades are 10 overall. I gain 1 and lose 11, or I gain 11 and lose 1. Trading in tens. So this is like the, GMAT master path. Again, to be fair, I didn't do that the first time I got this question, so you don't have to use the master path to get a really good score. But for study purposes, it's helpful to find. Okay. Any questions about this one? I just think, again, I think by making this map and by really thinking about it, it really forces you to think hard about each arrow. And those are the arrows, you know, this is where the work is. It's that arrow, it's the move from one piece of information to the next. That's the hard part. And there's usually one really hard arrow. One or two. Okay, let's keep moving forward then. Let's do this one here. Take 2 minutes. Okay, about 2 minutes. See some guesses of 1. I see a guess of 3. Here's what my scratch work would look like the first time I did this. I don't actually remember the first time I did this question. I think it might have been for this exercise. I know that I have 3 boxes, and I know that the median is 9, and I know that the average is 7. Okay, so that gives me that the total is 21. And I know that the median is 9. So that would tell me that if I call this box A and C, A plus C must be 12. And so the biggest is I want to maximize this lightest box. I want to make this one as big as possible. So I'd say that that's 3. And that would be answer choice C. So that would be what my work looked like. What does the inference map look like? Where did I make inferences? How did I make them? What inferences did I make? Try to take 2 minutes here and identify what the logical progression was to get to that answer of 3. While I sip my LaCroix, a refreshing beverage, 0 calories, great taste. I should be sponsored, Neil. I'm not. LaCroix, sponsor me. Sponsor Manhattan Prep. Make my company some income. Think about it now. It's not a terrible idea. I know. It's not the worst. If we have free audience, once every 2 weeks of a few dozen people, sure, why not? So I have 9 as a median. I know the average is 7. How did I get a total? How did I get to 12? How did I see that that meant that this was 3? Where does the information synthesize? If you're at home, pause and keep working. But this is the inference map that I made for myself here. If the average weight is 7 and there's 3 boxes, I know the total weight is 21. If the median weight is 9, and really I should probably have synthesized this with 3 boxes, because the fact that there's 3 and not 4 changes the situation, right? 4 boxes and the median is 9. It's a very different situation than 3 boxes, the median is 9. So I know that the middle box must be 9. Well, if the total is 21 and one of them is 9, the other two must be 12. How did that mean the smallest box at the maximum weight would be 3? Well, let's be a little more specific about that last inference. Okay, a little typo there. That heavier box, box C, it can't be less than 9, because then that messes up the median. 9 is the middle. If the median weight is 9, C is 9 or more. A is technically 9 or less. But it's going to be hard to make A 9. That would not work, because then C would be too low. But since C has to be 9 or more, I want to make it as small as possible to maximize A. The smaller C is, the more A has to make up to get to the sum of 21. Or if I'm looking at just A and C, the sum of 12. I want to maximize A, so I want to minimize C, and C can't be smaller than 9. So I put it as 9, well, that leaves A to be 3. And so that's the max weight of the smallest box. And this logic, these inferences, are mapped here in the scratch work. This is the scratch work, and this is the extra, right? This is what I mean when I'm like, this is not what you write on the test. This scratch work is what I write on the test, but it's a representation of this logic, of these inferences. And there's several steps there. There are several moments to make an inference. It's not, it's very tempting to think that people who do well in the GMAT, they take in information and they spit out an answer, like trivia, right? You just know it, boom, boom, boom. That's not what it's about. It's about the process. It's about the roadmap that goes from these givens to this answer. Okay, and this is a mental representation of the roadmap. This is the scratch work that you do to organize that mental process. But these are the inferences that are made. I know I get repetitive here, but I just think it's a cool exercise here. We have a few more, and we'll wrap up for the evening. Let's jump to, let's just jump to this last one here, actually. This will be maybe 1 or 2, but let's definitely do this one. The harder question here, take 2 minutes. All right, gang, so for this question here, I turn 450y into 45 times 10 times y. I turn that to 9 times 5 times 5 times 2 times y. I turn that into 2 times 3 squared times 5 squared times y equals n cubed. And so I then determined, oh, y must have a prime factor of 2 squared and 3 and 5 times some other stuff. Let's call it k. I don't know about k. It could be others, but it's definitely got to be a 2 squared, 3, and 5. So the answer's got to be 1. Y must be divisible by 3, 2 squared, and 5, because those are those factors here. So I chose B. Doesn't have to be divisible by 3 squared, because I don't know if y has a second 3. Doesn't have to be divisible by 5 squared, because y doesn't need to have a second 5. Could, doesn't have to. This is, which of the following must be an integer. So this is my scratch work. This is a very hard question, by the way. What are the inferences, though? And I'm actually going to show you here. I mean, this is basically what I just did here, right? So I know that 450 equals 2 times 3 squared times 5 squared. Why do I do that? Because I'm doing division and I'm asked about integers, and I know when I'm doing division in integers, it helps to find prime factors. So I got the prime factors of 450. And I know that 450 times y is n cubed, so that means that this equals n cubed. And I know that y and n are all integers. And so that let me know that y must have factors of 4, 3, and 5. But this arrow, I suspect, is the nightmare arrow. And when you're studying and you're reading an explanation and this, someone lays out something like this, you can really pinpoint, like, wait a minute, why though? What's going on? What is someone thinking to get 4, 3, and 5 are the factors of y, or must be factors of y? And what you can do is you can break down that arrow into several different sub-inferences. Right? Almost every complicated inference you can break down into smaller, simpler inferences. I chose this question because that's a hard inference to make, especially if you're not particularly studied in number properties yet. So why might that happen? Why might we be allowed to make that inference? Well, let me go a little bit into a diversion here before we go to the y must have factors of 4, 3, and 5. How about this sub-inference, right? If this is true, then I know n must be even. And let's just start with that for a second. Let's forget the multiple 3 part, right? That just makes sense, because if 2 times a number equals n, 2 times a number is even. So n must be even. That's an inference that I can make. Same thing as a multiple of 3. Because this 3 times some numbers must result in a multiple of 3. 5 times some numbers must result in a multiple of 5. Whether it's n or n cubed, right? This number must be even, it must be a multiple of 3, and it must be a multiple of 5, because this number is even a multiple of 3 and a multiple of 5. But since n is an integer, I can't just, I can't have like root 5 become a 5. I have to start with 5s. So if n is a multiple of 5, n cubed must be a multiple of 5 cubed. 125. N cubed must be a multiple of 2 cubed, 8. And n cubed must be a multiple of 3 cubed, 27. So by knowing n is even and n cubed is an even cubed, I know n cubed is a multiple of 8. Knowing that n is a multiple of 3, n cubed is a multiple of 27. Knowing that n is a multiple of 5, n cubed is a multiple of 125. So I know that that's true about n cubed, and I know that n cubed equals this thing over here. Well, so what's missing? I'm missing the 4. So a little synthesis here, what I can say is that this number, since it is n cubed, this number must be a multiple of 8, 27, and 125. Well, if this number is a multiple of 8, I have a 2. The other the 4, the 2 squared, must be in the y. If it's a multiple of 27, I have the 9. A 3 must be in the y. If it's a multiple of 125, I have a 5 squared. The other 5 must be in the y. And so I know that y must have factors of 4, 3, and 5. And so therefore, y must be divisible by 3 times 4 times 5. There might be another 3, there might be another 5, I don't know. This is a must be question. It must have a 3, it must have a 2 squared, it must have a 5. Okay, so I took that, oh, that was just one less little synthesis here. If you need to specify this last inference, okay, we know 2 times 3 squared times 5 squared is a multiple of 2, 9, and 25. Just so the y must have the other 4 and the 3 and the 5. It's just a more specific visualization. But the point here is that someone who's really good at divisibility goes right along that red arrow, the GMAT master path. Why? Well, because they've studied and understood and synthesized all of this so that it becomes one step. If you can automate something, if you look in your inference path, first off, go as specific as you need to go. If someone's explanation is too vague, drill down, find the individual steps that you need to take to make each inference. And then if it all logically follows, you can build like the neural shortcut to just recognize, oh, I need a 4, I need a 3, and I need a 5 because this is in cubed and I only have 5 squared. I need 5 cubed because this is a number cubed. So I need another 5. I need another 3 because that's 3 squared and I have a number cubed. I need 2 2s because I have 2 and I need a number cubed. So you can get to that red arrow, but you need to understand these steps really thoroughly for that red arrow to be locked in well enough to use in the future. Okay. So these are inference chains. They force you to be very specific about where information synthesizes, what information means, where you use your givens, where you bring in your own understanding from your GMAT studies, using the topics and concepts of the GMAT tests. Okay, but it really forces you to drill down and see how information logically progresses from givens to answer. And again, some of these are pretty complicated and sophisticated. There's a lot of, especially if you don't the GMAT master way, right? This is the 750 plus. This is the 700 plus. And there's nothing wrong with the 700 plus. 700 is a goal score for almost all my students. So if this is what you have to do, that's great. If you can do it, great. If you're trying to improve from here, yeah, prime boxes, it would be a good scratch work for this. Someone mentioned using prime boxes. But that's the scratch work. That's the representation that this logic is. The logic is this. How you use scratch work is a different question entirely, but you need to come up with scratch work that captures the logic well and lets you move through the inferences in an organized way. But understand what the inferences are in your review really deeply, and pinpoint where are the snags, what arrow causes me the most grief. Okay, take that arrow and drill down even more into sub inferences. And where's the snag there? Drill down even more. This is a review tool. It should really help you think, really force yourself to think very step by step, very logical, and to see which inferences give you the most grief. So I'm going to wrap up there for inference chains. Again, check out our website for upcoming courses. Come to those free sessions. Come to our free Foundations of Math course. I teach several of those. I'd love to see you there. I'm going to stick around now for the in-person group to answer any other questions. Otherwise, best of luck in your studies. Hope you use this in some of your problem solving review, and I will see you all next time.